Oh my goodness. Greg went out looking for a hack. Hey, what's up, Knight Rider fans? Alyssa Knight here with the brand new Hey, what's up, Knight Rider fans? Alyssa Knight here with the brand new episode of Knight TV. And if this is our first time meeting, I'm Alyssa Knight, and this show is all about hacking and securing embedded systems. Now, if you missed last week's episode, we built a rogue base station using a Nuand BladeRF X40. And that BladeRF supports 300 megahertz to 3.8 gigahertz on the frequency range. Now, this episode, my BladeRF 2.0 micro has finally arrived. And the 2.0 micro actually supports 47 megahertz to 6 gigahertz. What does that mean? It means the 2.0 micro now supports 5G. Now, unfortunately, there's some issues and challenges with yate-bts and the 2.0 micro that Robert Gildota and a good friend of mine, Chris Patterson, helped me work through. Rob over at Nuand was working through these issues, and they did realize that there are some systemic issues with the yate-bts. So Nuand actually created a custom distribution of yate-bts that you can download. I'll give you that URL in this episode. We'll also walk through the configuration and installation of yate-bts network in a box, get it up and running, and point it at the local loopback interface for us to throw Wireshark at to sniff the packets of devices that are connected to your rogue base station. Now, in our use case, we're performing a penetration test against connected cars, in this case specifically telematics control unit, which is associated to our rogue base station and will allow us to actually capture those packets. Now, this can of course be used in any penetration test against an IoT device that talks GSM. So if this is the episode that you've been waiting for, if you're interested in the 2.0 micro, how it works and how to get it working with yate-bts, then this is an episode you don't want to miss. So sit back, relax, grab that cup of joe, and join me for yet another episode of Knight TV. Okay, we're gonna go and get started now. The first thing you wanna do after doing a fresh installation of Ubuntu, which is what I would recommend because I ran into so many problems trying to take through the Ubuntu installation that I had created before and had set up the X40 with, and trying to configure everything again with the 2.0 micro. I just had a lot of problems, and they were problems that Rob and Chris really couldn't help me figure out. Like, they weren't seeing the same issues. And so what I found by reinstalling Ubuntu, just blowing it away and doing a brand new installation of Ubuntu, is a lot of those problems disappeared. So if you guys set up Ubuntu before following my other video, you'll find that the steps here, there aren't any steps that you don't need to do. Whereas in the last video, we installed some things like GNU Radio, GQRX that you really just didn't need to do. So this will, hopefully you'll find that this will be a lot easier than the last video that I created. So unless there's anything important on Ubuntu that you want to keep, my advice is go and just blow it away. The other thing is we were seeing some issues and having some challenges around VMware. So if you can install Ubuntu on bare metal instead of in a hypervisor, do that. There's just a lot of challenges and problems with running it in in a hypervisor, dealing with virtual device drivers and all of these other issues, I/O problems. You're building a rogue base station. You don't want to have to deal with issues that you may be confronted with running it in a virtual machine. So after installing Ubuntu for the first time, you're going to want to go ahead and run apt-update and apt-upgrade. Again, just like in the last video, I will paste the commands into the comments of this video. I'm not going to go into detail about each and every slash and dash in my narrative here. After the update and upgrade completes, we're going to go ahead and add the BladeRF PPA and install the BladeRF tools and libbladerf. So once that's done, you're going to just simply do an add-apt-repository PPA nuandllc /BladeRF. Then once that's been added, you want to do an apt update, an apt install BladeRF, apt install libbladerf-dev. Add group yate, and here with yate, we're simply just creating a group for a non-root user, in my case alissaknight, to be able to run yate without running into issues like needing to be root. After we've done that, just run a usermod -a -g yate alissaknight. That adds your username. In my case, it's alissaknight. In your case, it'll be something else, obviously, to the yate group. Unless you want to create a username alissaknight on your system. That would be a little creepy, though. Apt install lib usb-1.00-dev. And you're off to the races. Next, we're going to download Nuand specific yate. So what happened was, like I mentioned, Rob and the folks at Nuand saw all of the challenges and problems in compiling yate and yate-bts and getting it to work with the new BladeRF 2.0 micros. So they actually created a custom distro of yate that you can download. So here we're just running a wget nuand.com/download/yate-rc.tar. Once that's done downloading, we're just going to run a tar xvf yate-rc.tar. And one thing that got me was needing to realize that, well, there's a yate directory and a yate-bts directory created. So go ahead and mv yate to /user source and yate-bts to /user source, and then move the FPGA images by doing an mv star.rbf to user share Nuand BladeRF. Next, we're going to compile yate, and that's an apt install autoconf, gcc, g++, and make. Those are the packages you're going to need in order to compile yate successfully. And then just simply cd into /user/source/yate, and then run autogen.sh, configure -- prefix equals to user local, make install no API, and then ld-config to update your LD library paths. Next, we're going to build yate-bts, and we're just simply going to cd into user source yate-bts, do the same commands, /autogen, /configure, -- prefix equals to user local, make, sudo make install, and ld-config. Once that's done, we're going to want to set our permissions properly, since we are hopefully going to be running yate as a non-root user. So you're going to touch user local etc yate snp data conf and user local etc yate tmsi data conf. You're going to chown root :yate to user local etc yate star.conf and chmod g+w user local etc yate star.conf. Next, we're going to go ahead and set the transceiver scheduling. I'm a VI girl, so VI user local etsy yate-ybts.conf. And we're going to add the values radio underscore read underscore priority equals to highest and radio underscore send underscore priority equals to high. Once we're done with that, we're going to go ahead and install Apache 2 and PHP for network in a PC or NIPC. I think it was formerly called Network in a Box or NIB, but I think it's been renamed to NIPC. So once you have all of those packages installed, just apt install Apache 2, add the apt repository, the PPA for PHP, which is ondrej, PPA ondrej/PHP, apt-get update, and apt-get install PHP 5.6. Next, we're going to install Network in a Box for the web UI, and that's cd into /var/www/html. ln-s, you're going to create a symbolic link from user local share yate NIPC web into NIPC. And that's just the htdocs, the document root directory for Apache. chmod -$RA+RW user local etsy yate and etsy initd Apache to start the Apache daemon. Once that's all up and running and done, we're going to plug in the BladeRF and soft load the FPGA. Now this is really important. You guys cannot let Yate load the FPGA. You have to soft load it manually yourself. And that's simply just BladeRF -CLI space -L, and then the name of the FPGA. In my case, it's the A9, so it's hosted xa9.rbf. And now there's an issue, there's something funky going on with the 2.0 where you actually have to wait a few minutes once you soft load the FPGA. So you need to go ahead and run Yate after 2 or 3 minutes. So once you soft load the RBF file, wait a few minutes and then run Yate. And here you can see me modifying the configuration within the NIPC web interface. If you guys want to know your MCC and MNC, I'm going to put in the comments how to actually put your iPhone or Android into field test mode. And you can actually grab those values right off your phone. You can also head over to a website called mcc-mnc.com, and you can get those values as well for different local carriers. So the most important thing here is making sure you enable the GSM tap, and that's with the within this interface. You guys can see me here checking it, making sure it's turned on, and then loading Wireshark to point at the local loopback interface, and that GSM tap will allow you to see the packets traversing over the local loopback interface for any device that's connected to your rogue base station, in this case our telematics control unit. So that's it. It's that simple. We've in this episode configured successfully and installed all of the tools that you need for the BladeRF, including libbladerf. We downloaded the Yate distro created by Nuand that will work with our 2.0 micro. We compiled Yate, we compiled the BTS, we set our permissions, we set our transceiver scheduling, and we got Apache and PHP up and running as well. So if you guys have any questions, please definitely put them in the comments. Hopefully this has been valuable for you guys. Several of us really battled this over the last week. It's been really tough, but we got through the challenges. That's the purpose of content like this. If you guys have any suggestions for future shows, if there's anything you guys want to talk about regarding the BladeRF 2.0 versus the X40, please definitely put them in the comments. Definitely join us for the next episode of KnighTV, and thank you so much for supporting my content. I really wouldn't be here if it wasn't for you guys. So check out my other videos, my other playlists, help drive my watch time up on YouTube. And take care of yourselves and each other until we see each other again. Bye-bye.